Hi everybody. I'm recording this video for instructors who are considering using peer instruction in their classroom. And what I'm going to do for you is to walk you through an actual lecture. Actually, it's really about 2 lectures, I'll give you the truth, that I've used in an introductory programming class. And my goal is for you to see the real set of every slide that I used in this peer instruction class, so you get an idea of how the flow actually works and what I actually do. I promise I didn't change anything. Well, actually I changed one thing because I saw I could have improved it and I wanted to point that out to you. But this is really just sort of how it goes. Again, this is an introductory programming course. We use an approach called media computation. You see a picture of the book up there. And again, at this point I was kind of falling behind, and I had asked students to review for this particular class. This is talking about, we've already started doing some while loops in the book. I think we're starting about 4.3.3 in Mark Guzdial's book, which is called Increasing, Decreasing Red, or Green or Blue. And you can see that for the next class, I'm giving the students the exact pages I need them to read. This was a 50-minute class, so I'm actually only asking them to read a few pages because I know that I'm actually not going to get through all my stuff today. And I'm, of course, reminding them about discussion section. Now, what are these things down here at the bottom? So I have my students set in assigned groups of 3 to discuss their clicker questions with each other. And they'll work with the same 3 people all term. I'm concerned about one person dominating the group. I know that in intro courses this can sometimes happen. So during the second week I introduced these 3 icons. We have a turtle because we started off using turtles in this course for programming. We have the UCSD Triton, which is our logo, and we have the Java cup. So these 3 images show up all the time, and this red arrow migrates between them. And basically in week 2, I asked students to identify amongst the 3 of them, each of them would pick an icon. And so each day I say, hey, everybody who's the Java cup in your group, raise your hand. So I do it out loud and ask them to raise their hand to self-identify so that everybody can see in their group who that person is. And I say, Java cups, it is your job today to start all the discussions. Can I ensure that that actually happens? No way. But it gives the students the social incentive to be able to take over the conversation or take control of it and not be pushed to the sideline if they so want to. All right, so, I will say the one thing that I did change is I pushed all my titles over to the right because I'm hoping to put my video up on the left. Sometimes I have them centered. I do start with every class with a set of learning goals. You can see we're getting 13 through 19 in here. I don't actually read them for students, but I find that I provide them to them so they can use them to study, and I find that these are really helpful to me to make sure I'm having them do exactly what I want to do. And it's not that you'll find a clicker question for each one of those, but it'll be kind of close. So this gives you an idea of what we're going to do. Argue about the best location of a print statement to debug a problem with the loop. We'll do that. Apply knowledge of how people pass racquetballs to swap values of variables. That's not a clicker question. That's an activity. I'll tell you some more about it later. So let's go on. So I do start with a small lecture slide here. This is called Rules of Memory Model Drawing. I made this up. Mark has some stuff where he shows students how to diagram how things are happening with the various variables, etc. in the book, and I don't particularly like it. My way is not great either, but it is what I've done in the past. So at this point, I actually spend several minutes on this slide and I say, hey, here are the rules. You should print these out. You should have them with you. And the next thing I'm going to do is walk them through an example. I use a tablet PC in my class so I can write on my slides. I'm not using that right now, so I'm not going to show you. So basically, I ask them, or I then work with them, and I show them how I would draw the memory model for this particular piece of code. And this is going to take us 7 minutes, 5, 7 minutes, something like that, because I'm going to go through each part and show them how I would cross values out and update them and this, that, and the other. And of course, you got to tell them that you're going to make them do that on a quiz so that they'll do it. But then I have this question. So this will be our first clicker question of the day. And it's the same code that we worked on before. And I train students to know that if code hasn't changed, then it stays that same color. So nothing changed there. And this is one of the first places I really sort of and start indoctrinating students into recognizing that when you read a piece of code, you should know what it does. So I go through the standard, they vote individually, it's silent, then they discuss it with each other, and then they vote again. And you can see what my options are here. They're not, there's something you can easily read. Removes all the red from the picture. No, it's not doing it. By the way, I think the answer is, let's see, we get the red value, we decrease it by half, and then we reset it. So it should be reduces the red component of each pixel to half of its original value, D. So I provide some options that are maybe common distractors. Maybe I actually don't need A. This is back in the day when I felt like there were 5 buttons on the clicker and I needed to have 5 answers. I've decided that's not really a good thing. If I were rewriting this, I would probably just use B, changes half of the red pixels to not be red. Why not? Reduces the red component of half of the pixels. So this idea that they see the 0.5 and they may not understand what that applies to. Sets the red component of each pixel to half of its value, which is what it does because it multiplies it by value, or the other option of set the red component of each pixel to 0.5. All right, so they're going to argue about each of these, and I'm going to ask them to explain to me not only why is that answer right, but why are the other answers wrong. And that will actually, in fact, get some of them to tell me, well, if you wanted it to be C, for example, maybe you do a pixel array dot length divided by 2. And that would give you the first half of the pixels. So we'll be able to get them to sort of redo the code to tell me how I could make the other answers correct. I immediately actually go on to another question, and I'm probably going to be a little wary, let me go back, of being really clear about B and C in terms of what half of the pixels will be, because the very next question is going to ask them this. So it's the exact same code. I point out any differences in the code, because this is a lot of stuff to look at. I mean, you're looking at it for the first time. You'd have to take a few minutes to read it. The goal I want students to have in the class is to say, you don't have to reread all of this. Let me point you to the part that changed. I put it in bold red. So I say, exact same code as before, but I changed the while loop expression. And I'm asking you, which pixels does this code modify? Now here's what's interesting. So it's pixel array dot length divided by 4. And the answer is in fact C. My drawings are clearly sort of haphazard, and I'm not into like spending oodles of time doing really nice pictures in PowerPoint. You may do so if you like. But what's really great about this question is this is not answered anywhere in the textbook. I think I either empirically figured it out or I called Mark or emailed him and asked him what the answer to this, what this would be. He doesn't actually talk about that I recall, how the array is laid out, but it turns out it goes across the rows and then down the columns. And so this is going to be a great argument for them to have between C and D, and I don't really know how they'd come up with an option for A or B, but it reflects a quarter, so that seemed like a good idea. And I immediately go into another question. So now, again, I've changed in red. I said I modified a few things, okay? Actually, the stuff that's in the loop it stays the same, but I changed the loop header again. Now, this is an interesting one. Some of you who are computer science professors might have noticed that I said debugging at the top, and I want to indicate to students that I'm particularly asking them to turn on their debugging brain at this point. I'm not trying to trick them like that they didn't happen to notice, by the way, the semicolon at the end of the while loop expression. Yeah, there's not supposed to be a semicolon on that line that says section C. That's a common error students make. So I designed this question to get them to encounter that error and then talk about what actually happens at that point, okay? And so I want them to not, just go, oh, this is an easy question. I asked them the same question without that error the previous lecture. But so I tell them it's debugging, and I think that's an important thing. The other thing I've done here is I've labeled these sections of code, and the key answer is I'm asking them to choose A, B, C, D, and I'm asking how many times is each set of code executed. And this is the hard part for students about loops, is recognizing that things that are outside the loop happen only one time, things that happen inside the loop happen many times, but also that the Boolean expression of the loop happens many times, okay? Now that would be the normal answer without debugging. The correct answer in this particular case is, I hope I have the right answer here, it should be 1, 1, many, and 1. So apparently I don't have the right answer, which is really cool. I should have E, none of the above. And maybe I had this as an error. I can't really recall. But this was the slide I used. I promised you I didn't change anything. So the idea here is that this while loop should, while index less than pixel length Actually, that's going to, I think, loop infinitely because I never change index, because this says the loop happens, there's no element or items, no statements in the while loop body, so it's going to run infinitely. And then if it were to complete, which it's not in this case, then these would actually only execute one time. So sometimes, just remember, even if you make a mistake when you're trying to do peer instruction for the first time, it can come out great as long as the students are arguing about it. That's what you really want. If you want to try to cover yourself, you can always have E, none of the above. And then that can be a choice students can have, but this is great too. And this is another reason why I don't recommend giving students points for correctness on these discussion questions, because it's not so much about getting it right as it is about analyzing and arguing it. Here's my next question. So it's the same piece of code, but I'm saying, okay, you found out what the error was. Oh wait, I don't have a semicolon at the end of this one. That's good. But I said, how would we debug this? If we wanted to put a print statement to see what is happening with our loop, what would be the best place to put it? There's probably not one right answer here, and honestly, I'm good with either C or D. But I want them to realize that putting the print statement before the loop happens is not going to help them understand how many times the loop is running and what the values of the variables are. I don't even know how you'd put one in to the while loop header Boolean expression, so I want them to say that to each other. Could I put it there? How would I do it? It turns out you can't. You might be able to in a for loop in various ways. And then, I'll say that either B or D could be a valuable place to put a print, and I'm going to ask them, what would you want to print? Well, index in this case would be the thing they'd want to print, but I don't have to ask them that. I won't have that come up in the discussion. But I'll say either C or D could be correct, but you just need to be able to know where your print statement is and what values you should be expecting to get. Have another debugging question. This is, that time in the term where they're really actually starting to do reasonable homework. So showing them, getting them debugging with each other and arguing about code that is incorrect seems to be a very important thing, I would think, to spend time on. So in this case, I tell them what the code should do. This code should swap the red and blue components at each pixel, but what does it actually do? Okay. Now this is a new piece of code, so I'm going to have to give them a few minutes to go through it. And depending on the class, I might even talk them through a little bit about what's going on. I might read the code to them to encourage them to read each line. As the term goes on, I try to do less and less of that because they know more that they should read each line of code, but this is early in the term. So what does it actually do? I give them an option that has a compiler error. Always a good one, just to see if they can, look at that carefully. But that may not actually be something that you care about. But the real options here is it sets the red value to be the same as the blue value. It sets the blue value as the red value, or it does swap. Okay. I could, in fact, probably pull out, well, I think I would probably get rid of A at this point, and hopefully I don't have any compiler errors, and I tend to make too many of those on code. But what we've got here is you can see that we're overwriting, we get the red value, and we put it into value, and then we overwrite it with the blue value. So in fact, we're going to put the blue value in for both red and blue in the set red and the set blue. Okay, so that's going to be our error. And I believe what we have next, so hopefully, again, students will be there. So in this case, it sets the red value to be the same as the blue. We didn't explicitly state that it leaves the blue alone, but we could. But what I'm going to bring in is, the reason I had them doing that is students are notoriously challenged at doing swapping of values in variables. Okay, this is well studied, well, not well studied, this is studied pretty well in the literature, and Ray Lister in Australia particularly has some good things about this. So I had actually already had an activity where I bring in 2 racquetballs and I have students come up and hold them in one hand. So at this point I'm going to go off, and it's probably going to be about 5 minutes. I'm going to have students do this swapping back and forth, and we're going to keep track, and they're going to realize that, when the person with the red hands the person with the blue something, they can't hold 2 values in one their hand. And so they're going to need a friend to come along to hold that extra value. So a temporary variable to hold that extra value so that we can make the swap happen. And I actually have them act that out with people at the front of the room. And that gets them to remember whenever they're wanting to swap, they're going to need a friend variable or somebody an extra temporary variable to hold a temporary value. So once I've had them act this out and learn from it, then I'm going to ask them to identify the code that will actually make this happen. So again, using the red bold to show them what code that goes here, And I will admit, this is the one slide I changed for you because I originally had value equal pics.getRead in each of the options. And that's a bad thing to do. You want to keep each of your options as simple as possible, focusing the students on reading the things that are different in each of the pictures. And you want to try to help them out. So I would probably actually tell my students in class, by the way, A and B set blue first and C and D set red first. That's the thing that's different. Now you need to look at the stuff that's in the parameters to further do that. But this one's going to take them quite a bit of time to look at and read. So I need to give them plenty of time to think about this individually before they do it. And if they want to get out a little pencil and paper and write stuff down, that's fine too. All right, so now we're moving on to for loops. This is still in chapter 4, but this is a big change. And here's what I want you to realize. We've been working on while loops. It's true I had some slides on while loops before we came here, but I never had the slide that said, here's the structure of a while loop. It's got a Boolean expression here, and these things execute multiple times. I expected them to get that from the reading. And the same thing for the for loops. This is my very, very first for loop slide in this class. I didn't ever say to anything about here's the initialization, here's the whatever, but I do know that students struggle to understand the structure of that for loop header. Okay, and I made another error again. I'm pretty sure that semicolon isn't supposed to be there, but there we are. So I want them to be thinking not so much about the details of what the for loop is doing, but which things execute one time or many times. So the answer to this one, assuming my semicolon is an error, and I would mark it out in class, it was an unintentional error, would be that section A would be executed once. That's the initialization. Section B, this one they miss all the time. That one should be executed many times because we check the Boolean expression at the top of every for loop. C, that points out that update index that happens many times. And D, that's the loop of the body that happens many times. So you can imagine that the discussions about this, because I use one and many and not like 1 and 10 or 1 and 100, really focus them in on the core things. I want you to understand in loops, some things happen many times and some things happen one time. And I think this is my last one of the day. I'm asking students to pick a picture. Again, you can argue with my lack of drawing ability or cleanliness or messiness, whatever. But which picture most accurately describes what this code does? So previously, I have them talking about, picking in English what the code does. I want them to also learn that when you're shown a piece of code, you should try to have a mental image of what's happening to the code in that array. So using this kind of a clicker question, I can say sort of, a little bit through subtext, and then I say it very explicitly in class. So when you're writing code, you should draw a picture of what you think is causing it to happen in the array, and then work that out from there. And I think that's it. And again, I'm pretty sure this actually takes me probably almost 2 full 50-minute lectures because there's some really deep nitty-gritty stuff there. Hope this was helpful.